What is the coefficient of x in the following expressions? Since this is only our second lesson of the year, a lot of you guys forgot this very long and extremely hard to spell word, coefficient. Coefficient is the co of the efficient, all right? The efficient is the x, and its co is the number with it. So for number 1, the coefficient of x is -5. Now here's the problem though. Some of you guys are going to write -5x. If you do that, you're going to lose points on the test. So don't do that. Additionally, some of you guys for number 2 would write 13 as the answer for number 2. That is false. Yeah?
It's -13.
That is correct. The term here is -13x, therefore the coefficient is -13. Bam, that's a good one. So is this one. 3 is the most difficult of all 4 of these because the answer is just 6. And you guys usually want there to be some kind of catch or trick to these things. Not on this one. Number 4. Again, some people would mistakenly put 72, but it's a decimal, 0.4. Still mistaken, they have forgotten the negative. There we go. So this is a fair question. Let's look at the number 5. We'll make one up. What is the coefficient for 5 squared?
Zeros. What? There's no coefficient.
There is. Because, as you guys haven't learned yet, we could easily add 0x to this. And then the coefficient is 0. On the other hand, though, and this is another tricky situation, is what if we just have x plus 82? Well, then we have what we call a phantom Juan in front of the x, which tells us that we have one x. And the coefficient is a Juan. Not the person, but the number. These are the answers to the homework. Some of these are just suggested answers, like in 7 and 8. 7 and 8 are worth 3 points each because it asks for 3 different expressions. And 18 has 4 different parts, therefore each part is worth 1 point. What you want to keep track of when you correct the homework is the number wrong that you get. Oh, that's a good recovery.
There's no 18.
Figure out, I know, it on the back it started over at 1. So I started at 11 for the back. So that there were no confusion, even though there still will be. You got to keep track of the number wrong you get, okay? We'll go over that in a minute. Is like number 1 here, right? See how I have 6x plus 6? If you guys had written 6 plus 6x, it's the same exact expression. It's just written in a different order. Later on, that will be important, just not in this class. And some teachers take that extremely seriously. I'm not one of them. So don't worry about it, okay? Last time we talked about that form ax plus b. That's why they take that. They're really strict about that stuff. So let's go through this thing. Let's say that I missed 1 point on number 7, and then I missed 1 point on 9b, which was worth 2 points. And then maybe I missed 14 and 5 and 2 and 18b and 17a and 12 and 15 and 6. All right? So I've marked those wrong for me, and I say to myself, self, how many did I get wrong? Well, I can count them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is how many I got wrong. Hopefully you got less, maybe more, whatever. Okay, so I said 10 wrong. So on this chart, I see on the bottom there, if you can read it, it says the number wrong. I didn't get 0 to 3 wrong, or 4 to 6, or 7 to 9. I got 10 wrong. Therefore, my score is a 7. And so I say I got a 7. All the homework assignments will be out of 10. You don't have to say 7 out of 10, but I'm going to take scores. All you got to do is say 7. In the lessons up to this point, all one of them, we've been working with linear expression. We reviewed how to simplify a linear expression and how to evaluate a linear expression for a given value of x, which is something you should have learned last year anyways. We will now begin our work with linear equation. When we solve a linear equation, our task is to find the values of the unknown to make the equation true. So as it turns out in the past when you guys have done this, if you did, and you said in the end, well, x is 5, then you would plug it back into the equation to make sure it's a true statement. Otherwise, you may not have and got it wrong, and then the teacher gave you -5.
Do you mean C?
C is not 5. I'm just giving you an example that's very arbitrary. Just an example. So, when you guys are solving equations, as it turns out, it's extremely important to check your work. Unfortunately, out of each class, maybe I'll get 2 or 3 of you that will check your work, and the rest are just kind of lazy and stop by just finding the answer. Just know if you stop there, it's okay. It's not required that you check your work, but you are taking a risk. Some of you guys like to cheat. Well, hopefully no one does, but some people still do. And checking your work is kind of a form of cheating. We just encourage it, and it's legal, all right? You can ask the principal, man. He'll tell you every time, yeah, check your work. It's cheating. Do it. But any other forms of cheating are no good. So let's read this problem. Damien and his friends went trick-or-treating. The next day, they got together and counted their candies. Damien had twice as much candy as Nick. Bo had 10 more pieces than Damien.
Feel bad for Nick.
The following, well, no, he got plenty. The following model and expression represent the amount of candy the boys have together.
Well, it's just kind of sad.
Maybe. What if the candies are vegetable candies? Then he's in good shape,
Maybe it's the other
right?
kid that got the burst that was ugly and people thought it was disgusting, so they gave him more.
Yeah,
So-
that makes sense in Halloween, right?
Or maybe one of them's just really greedy. All of them are greedy besides Nick.
That would have to be a Josh, though. All right. I'm just joshing. Jeez. You guys got me started now. Here we go. We got 3 people. Damien, Nick, and Bo. So we just got to figure out in this model. We'll look at the expression here in a moment because you guys have that on your paper. But we got to figure out which part of this model represents Damien. So let's identify where it talks about Damien in the words. There we go. This one specifically says that he had twice as much candy as Nick. So we need to show somewhere where Nick has twice as much candy. Damien has twice as much candy as Nick. So how much did Nick have? It doesn't say anything about Nick other than in relation to Damien. So which of these would represent Nick? Excellent. This one right here would represent Nick. And in this part of the model, notice it's, I don't know what to call that. It's including 2 C's. So that would have to be Damien. Now, by the process of elimination, we could easily say that this is Bo, who has as much as Damien, which is shown right here, but then in addition to that, 10 more, which is what it says right here. It is highly crucial that you are able to, in a model or in an expression, to identify what parts of the expression or model are related to the problem, like we just did. Now we have this expression, but then it gives us also this 230 right here. And both of these are linear expressions. That's okay. Even the 230 is linear because it's just a number. And if we wanted to graph that, we could. Not that we're going to today, but eventually we will. They're both linear expressions and represent the amount of candy the boys have together, the 230 and that expression. When we set 2 linear expressions equal to each other, we create a linear equation. So with that in mind, what is the difference between an expression and an equation? Yes?
An equation has an equal sign.
That is correct. So let's write an expression, the first one there, C plus 2C plus quantity, 2C plus a 10, right here. This right here is an expression. We can also write another expression, 230. So to make this an equation, we just need to put an equal sign between these. Now it says to model this equation with your tiles. We're not going to do that right now because drawing 230 tiles is not really what I had in mind today. But we can solve this. All right, good luck.
Oops. How do I go down?
Do you want to explain any of that, or?
Okay, so you do 230 minus 10 to take out the 10 out of the parentheses. Then it's 220, and then you combine all the C's together to make 5C, and then you divide 220 by 5 so that it's just 1C, and it's 1C equals 44.
All right. Very good. If I saw this on a test, -1. Who can tell us what's wrong with it? Yes?
It's messy.
It is messy. I mean, I'll give you that. But I've seen a lot worse than this, so it's actually not too bad. No, it's not that it's messy. Yes?
He did the work correctly, he just didn't show it properly.
I'm satisfied with the showing here. I understand how this is done. I've seen this type of work before. Yes?
You didn't circle it?
Oh, that would have been good, I guess. But
That's what I was going to say.
no, it's not that.
Was just
It's something even more complicated than that. Here we go. See that?
Dang it.
Right there.
Label.
It's a huge difference. But yeah, look, no, if you don't label stuff on the test, you're going to lose points, all right? It's, I don't care about spelling. I mean, I don't even know if I spelled that right. Is it I before E or E after I before C? But except on holidays and Fridays. Okay. Well, this wasn't the only question as well. Now, there was more to this, and Josh did a great job solving the equation. There's another part to this. C, what does C represent?
Candy.
Candy for Nick, specifically. Well, if Nick got 44 piece, then how much did Damien get?
88. And
88.
98 for Bo.
Nice. And Bo got 98. And that's just using the expression there. Problem is you guys said 88 and 98.
Pieces of candy.
Pieces, there you go. So let's label those. There we go. Is everyone good there?
Yeah.
Any question? A solution to an equation is a number that makes the equation true, which we already covered. So the solution we found on the last one was 44. It should make that equation true, right? So this would be a good way to check, is to just replace all the C's with C represented next, which is, very good, 44. Now when I write this in there, that's not 2 44, it's 2 times 44, so I should probably put in some parentheses there. And if I solve the left side of this equation, I should get 230. Another way to do it is that we found that Nick had 44, Damien had 88, and then old Bo came in with 98 pieces, right? I could just check by adding these together, and how many should I get?
230.
Yeah, 230, right? Just to check it off. So both ways would work, and either way you want to do it is good. On the other hand here, it is possible for an equation to have one answer, and only one answer. It's possible that an equation has no answers, and it's possible for an equation to have as infinite answers. But those are very special scenarios, okay? How would you solve the following equation? Solve the equation showing all your steps, and then verify your solution. All right, good luck.
Okay, so we have to multiply the 3 to the x and to the 1. So that is 3x plus 1 equals 12. And then we have to subtract the 1, correct?
Sure.
And then you have to subtract the 1 on both sides. And that equals 11, and then you have to divide, you divide the 3x by 3, so you just have x left here. You have to divide 11 by 3,
No, keep going, you're good.
and that is some decimal.
We'll leave it as a fraction for now. That's very good.
Would you prove the fraction
Right.
answer?
Yeah, fractions are That is an excellent point. So, and notice he even put this in here. It's good for us to see the mistakes, by the way. So, this is an extremely good place to make mistakes. During the test is not. But notice he even put the line radical showing the distribution to the 1. But this is something that happens all the time, even on tests, is that it comes out as a 1 still. Now he even said it when he was doing the work, right? So technically we should change this thing to a 3. Now it's going to change this to a 3 as well, and this, which will change the 11 to a 9er, right? And what's 9 divided by 3? 3, man, there we go. So we're done on this one. No, we are not done.
You have to
Use
label
the
it.
label.
No, it wasn't a word problem.
X equals
You got to check.
Oh.
Yeah, with x equals 3, so 3 times, I'm replacing x with 3, radical. 3 times 3 plus 1 should equal 12, is more of a question mark, radical. By the order of operations, 3 plus 1 is 4. So 3 times 4, does it equal 12? Yes, it do. This gave us a true statement. Therefore, we know that our answer is 3, done. All right. Now here's the thing, is if, radical, let's say that we found it was 11 equals 12. Well, that's false, okay? I mean, even if it's close, it's false. So we'd have to go back and find out where we made a mistake. For example, if we'd put that 11/3 in there, we would have got something extremely different. And that's okay. It's okay to get something different. You just have to be willing to go back and check it again, which is probably why most people don't check, because they're too afraid they're going to have to go back and do more work. I don't know.
Okay.
Thank you.
So first you add the 4x plus 3x, which is 7x, and then you add the 1. So minus 1 equals 6. and then you add 1 to it, to the 6, which is 7. Wait, how do you like? Okay.
You need more
And then you
space.
do 7x divided by 7. Okay, that helps. Okay. And then you do 7 divided by 7, which is 1. Right? Is that right?
Is it right?
Yeah.
Did anyone check? Good. Is it right then?
I did it correct.
Yes, yes, it is correct.
What
If
if
we
you
were to
didn't
go-
check and you still got it right?
Then you're taking a risk. So 4 times 1 is 4, plus 3 times 1 is 3, minus 1. Does that equal 6? Yes, it does. This one checks off. Bam. 1 is our answer. Good luck.
I don't have to talk at all. I don't want. Okay. So this is a 1x. So that would be 2x plus 4. And then you're trying to get to 10. So 2 times 3 equals 6 plus 4 equals 10. And in my verify is if you substitute the x for 3, so negative 3, and then plus 3, and that's 9. So negative 3 plus 9 is 6, and then plus 4 equals 10. So x equals 6.
I'm gonna use the hall pass now, okay?
Can I use it after Josh, please?
And someone else was waiting. All right, so yeah, and I think she said 3 out loud, and she certainly checked with 3 as the X right here.
I said 3 out
So, yeah.
loud, but
No, you're good. We understood. Listen to what we're trying to say, not what we're saying, right? So X is 3, and it's been checked. We're good on this one. All right, good luck.
Okay. So,
Make sure you explain while you do it, though, please.
So you distribute. And that's 2x plus 10 equals 14. Then subtract 10. And then get 4. And then you bring down 2x. Divide that by 2. Get rid of the x. And then 4 divided by 2 equals 2. Then you plug that back in. And you put in 2x. Oop. Erase. Put 2 plus 5, and then that's 7 times 2 equals 14, so it's correct.
Bam. Everyone see how we verified that? 1 second. Excellent work. That is a great question. So you're talking about this. Why did we subtract 10, Radical?
yeah.
Before we did any division of the two? Who can answer that for us? Yes.
Because before you want, so to divide, you want to be dividing so you can get down to just the x. So when you still have the 10 and on the left part of the equal sign, then when you divide, you're gonna get more than just the x. You're gonna get like 2x divided by 14 or whatever. So it doesn't make sense because you're trying to get the x alone, and to get the x alone, you have to minus the 10.
Got it.
That is excellent. Now, I explained this a little bit differently, so maybe it's helpful, maybe it's not. But if we go back up in here, let's write this again. We got 2x plus 10, right? Equals 14. The answer, which is written right here as x equals 2, could easily be written as x plus 0 equals 2, right? I mean, if I add 0 to that x, nothing's really happening. Last year, you guys should have learned about this as 0 pairs. So what, and like she was saying, when you want the x's by themselves on their own side of the equal sign, so I need that really to be 2x plus 0 is what it comes out to be. So how do I make that 10 a 0? I got to subtract 10 from the 10. But if I do it to one side, I must do it to the other side as well. Bam, there we go.
We learned this last year.
That's right, in my class. I don't know if the other teachers do it exactly like this, but similar. Now what happens is we just don't write a plus 0. It's a phantom 0. All right, good luck.
I need it. Okay, so at first I'm going to distribute. So that'd be 6x plus 2.
What did you do?
I'm left-handed, shut up.
No, you aren't.
Yes, I am left-handed.
2 buttons down.
Okay, this.
There you go, yep.
Wait, no, hold on. Where's your erase? Okay.
Right there. There we go. Perfect.
Hold
Start
on.
drawing. Now.
Oh, wait, hold on. 2x. Now I'm going to combine like, wait. Then I'm going to combine like terms, which is negative 4. No. That's a positive 4. Just ignore that. Negative 4, no, positive 4x, plus 2, shut up, equals 10, subtract 2 from that, subtract 2 from that, that gives you just positive 4x equals 8, divide this by 2, divide that by 2, wait, divide by 4, divide that by 4, which gives you x equals 2. We're going to verify it with 2. There, and then I should have enough room. Okay, and then this 10, that's 12 plus 2 minus 4 equals 10, and that's 14 minus 4 equals 10, and that's 10 equals 10, so it's right. So x equals 2.
Excellent work. Good job to check that. All right, I know some of you guys are excited to do these. Sorry, we're just kind of pressed for time.
How is it 3?
So here's the thing is, you guys, we're going to have to distribute this -3, right? So this is what happens a lot of times on the test. We get 13 equals, that's now a -3x, and then I get -12 minus 8 right here. There's a big mistake that happens. It's a very common mistake in this as well. Who can tell us what it is? Yes?
Negative times a negative equals a positive.
That's correct. So you could either make this a plus 12 Or you could say that it was always just minus and that becomes a negative 12 radicale, which eventually is going to make that plus anyways. Okay? So just be careful in these steps because that right there is a very, very common mistake.
Or you can
So let's
just
continue
combine
this.
the
We
two.
got 13 equals negative 3x. And then 12 minus 8, bam, we get a positive 4 from these two. And then you're going to subtract 4 from both sides. And we get 9er equals, this is another mistake we see often, 3x.
Negative.
It's a very small mistake. It doesn't mean that you're doing it wrong, it just means that you forgot the negative radicale. And then we'll divide both sides by 3, and we end, I'm sorry, negative 3.